Hi guys, welcome to another quest. So, after the previous quest where we actually uncovered the mysteries of friction, how about we talk about motion? But then, not just any kind of motion, but rather circular motion. So, what is circular motion? Circular motion is the motion of an object along the circumference of a circle. Remember that the circumference of a circle is actually the total distance, or rather the total length around the circle. So, when an object travels in a circular path, it is called circular motion. Now, some examples of circular motions are the motion of a rotating fan, that is the blade rotating on the ceiling fan, and two, an artificial satellite orbiting the Earth at a constant height. A good and practical example is this. If you actually tie a stone to a rope and you swing it, that again is another form of circular motion. But now, using again this same illustration, we can actually note the following. That one, the length of the rope is constant. This shows that the path in which this stone is going to travel will be circular. And this only because the radius of the stone is actually constant. Two, that the direction of the stone is constantly changing. And how is it constantly changing? You will note that as the stone goes, it is actually moving this way and it's actually going in a circle. You will also note thirdly that the angle the rope makes with the starting line, that is where the point where you are actually holding the rope, is also changing. Now, if we assume that the speed of this stone is constant, and by speed I mean of course the rate at which the stone travels along the circle is always the same, then we can also say that the velocity of the stone is not constant. But then again, how can I say that the speed of this stone is constant and again say that the velocity is not constant? Now, hang on and I will show you how interesting physics can be. Remember this video or the lesson where we treated speed and velocity? Yes, we said that velocity is actually speed in a specified direction. So again, let's recall, what does this actually mean in a specified direction? Now, when I say I am traveling at a speed of say 5 meters per second, then that is speed. But when I say that I am traveling at a speed of 5 meters per second, that of course is velocity, because I will say I am moving from a distance, say from Abuja to Accra. In this case, I've actually specified my direction and hence this becomes velocity. You will see that in the first case, there was actually no direction. But in the second case here, the direction was specified, which is where? From Abuja to Accra. But recall also that we had earlier said that the direction in which the stone is moving is also constantly changing. This means that even though the speed, of course, is constant, but because the direction is changing, then of course, velocity is also changing. Now, one great idea about circular motion is this, that the velocity is always changing, even if the speed is the same. This is just because, as we said, because of the change in direction, and this direction is always what? Changing. Recall also, we had earlier agreed that the angle the rope makes with the starting line, that is at the point where you are holding the rope, we said that this angle is also changing. This again means that the angle is changing constantly with time. So, the rate at which the angle is changing with time is what we call the angular speed. So, how is angular speed different from the linear velocity? Let us actually illustrate this. Let's assume here that the stone travels from a point, say A, to a point B along the circumference of the circle. Now, if we measure this distance from A to B, and we say it is about 100 centimeters, and the total angle it covers while it moves from this point A to point B is actually 50 degrees, and it takes it about 2 seconds to move from this point A to the point B, then we can say that the velocity of this stone will be the distance, which is 100 centimeters, divided by the time it takes, which is 2 seconds, and that gives us what? 50 centimeters per second. While on the other hand, the angular velocity will be 50 degrees over 2 seconds, which gives us what? 25 degrees per second. Now, since the velocity is changing as we have just proved, recall again that change in velocity creates acceleration. Yes, of course. Acceleration is actually the change of velocity with time. But wait here. In the first instance, what actually creates motion? Yes, force. Force is actually responsible for creating motion, and hence, it will actually be unfair if we treat this lesson without actually including force. So, the force actually responsible for moving an object in a circular path is what we call the centripetal force. And also, this centripetal force always acts along the direction leading towards the center of the circle. Now, how about we actually stop here for now and continue this exciting discovery in the next lesson? Always remember to keep watching, keep studying, stay tuned to us because we've got you covered. See you guys next time.